Okay, so we're going to integrate the following integrals. So just by look, we want to see which formulas that we know so far are going to work this. And you probably have a hard time looking for one. You may think of it as by integration by parts, or you could think of it maybe by du over u, but it's not an easy fit. So it's really good luck. If you want to try them, go ahead. But the easiest way to do the problems, by the way, I selected 4 problems. One of the problems is really the one that I circled was asked by one of my students in my calculus class last class. So let's go ahead and start one by one. We want to find the easiest way without doing much work. That's our objective. Okay, so this happens to be our inverse trig functions. Okay, substitution. So that's what we're gonna do. So if I have something like this, I'm thinking of an integral that is du over a squared plus u squared, and this is simply 1 over a, so that's the formula of arctan. I write like 10 to the negative 1, arctan of the angle, which is going to be u over a, plus a constant, and we are done. So we're gonna make this look like that. That's the whole thing, and this is so easy. After doing one problem, I'm gonna make the problems more harder, more challenging, till you say, okay, bring it on, I can do any problem. That's the feeling we're gonna have after 4 problems. So stay tuned, please, okay, till the end. So in this problem, what I could do is do not touch anything there. I'm just going to rewrite the problem. So I'm going to write this down. This is equal to integral of dx over, instead of 16, I'm going to write down 4 square, plus, the next one is really my x squared. Just I'll write it down like that, the way it is. And then I'm going to go to the right. All the time we go to the right and write our notes. We're going to say that let u equal to, guess what? U is right here. So in this problem that we have is u is x. So let u equal to x. So just right here, that's my u. And du is equal to dx. That's the advantage of writing the formula just like this instead of writing by x, because I tell you where the u is. I always use substitution and making things so much easier for us. It makes it so much easy, unbelievable. And just put a note here that our a is right there is 4. We need that. So let's go and substitute, and we're going to be done. We're almost done there, okay? So remember that dx is equal to du, so I'm writing du, and I'm writing my a 4 is a, and I'm substituting right now, a squared. I want to make sure that I have everything plus before I use the formula. That x is u, so that's u squared. Once I do this, then I could say, okay, you know what? What's this equal to? That's equal to 1 over a arctangent of u over a plus c. That's what we're going to do. Once we are done with that, then you go back and you do your final substitution. 1. Remember, a is 4. Arctan of u. What's my u, guys? U is x. So u is x over a, which is 4, plus a constant. Okay, and we are done with problem 1. Okay, let's go to 2. Now I'm going to pause a second to see if you could do 2 by yourself. This time I'm not writing the formula. This formula is so easy to memorize. Usually teachers are, and during the HL IB calculus test, they're giving you the formulas. They have the formula sheets. I've given it to all my students. But even if they don't, it's so easy to remember that. So if you write do a couple of problems, you're going to do it. Now, the trick to do this problem looks maybe a little bit more challenging, but once you do it, it's exactly the same thing like problem 1. So you're going to, don't touch the top. That's the whole thing. That's my advice to you. And wait, don't make the decisions right away. Usually I tell my students to pull out the constant out. But in this case, we don't want to do that because we want to see if that is necessary. We're just going to wait. So let's be patient. We're just going to rewrite the prompt and leave the top the same way to see what happens. We're just going to write the dx on top all the time. And then in the bottom, I'm writing 4 is, remember, my a, so it has to be in a square form, okay? So we're going to write down this as 2 square. Plus, and same thing with my u is u squared, so I have to write down 2x to the third raised to the 2. And that's going to give me 4x to the 6. I'm almost done. I can see it. I hope that you could see it too. So let u equal to, that is going to be my u, 2x cubed. See, that's the beauty of the way we are using the formula in our classroom. And du is equal to 6x squared dx, which I have it on top. I just want to put a note here. Note a is equal to 2. To just remember that. And then I'm done. Okay, I'm writing. I'm writing my integral one more time, but this time I'm substituting. I'm saying, 6x squared dx. What are you? It says I'm simply du. So I said fine. I'm happy with that. If you're du, and this is going to be my a to the second plus u. Remember that 2x cubed is my u to the second. Okay, so what is that? That is simply 1 over a arctangent or tan inverse of u over a. So even if you're doing this for the first time, you're going to memorize it with me. Plus a constant. I memorized this. We know how to drive them, so I will do that later on. But right now, we just use the formula. And it's so simple. 1 over a, what's my a, guys? 2. Arctangent of, what's my u? U is right here, 2x cubed. Divided by a, divided by 2, plus a constant, and we are done with problem 2. Okay, so much for the arctan. We aced that. We know that it's going to be a squared and u squared in the bottom and du on top, and boom, we got the formula. Now let's move on to problem number 3. Okay, so we did 2. So let's go to 3. Okay, I pause here. This looks different. It doesn't look like arctan. So what is this? I bet you if you say that looks like sine inverse. Okay, these formulas, yes, that's sine inverse. Okay, so sine inverse. So how a sine inverse would look like. Okay, so let's write how a sine inverse would look like. It looks like this. If you have an integral that is du's on top, just like last time, but then you have a square root. Okay, folks, you have a square root of a squared. This time is minus x. Whoops, I don't want to write it in terms of x squared, my formula, okay? Minus u squared. I like to use u because the advantage of writing it in terms of u, I think you know that, is that where the u is, because u is always a challenge for us. And then we can say, okay, you know what? What's this equal to? This is really simple, one line. It's really sine inverse of u over a plus a constant. So easy to remember it. Okay, so we got that. Okay, and now I go back to my formula. It's strategy. It's all about strategy, okay? With me, it's all about strategy. Don't touch the top. Don't touch it if it's not. Why fix it if it's not broken, right? It's not broken, definitely. The objective of testing you on this topic is to know whether you know how to use the formula. It's not that you have to use substitution. Really, it's not that deep. Okay, I would say it like that. So this is really, it looks intimidating, but they're really easy. So look at the way we're going to do here, and then we're going to do here. We're just going to prepare it to make it look like this. And then 16, you guessed it, is 4 squared minus 25. So you're going to say, what raised to second power give me what's under the radical? Okay, so that's 5. Okay, so you can write down 5. Okay, it's moving. Let me just put it back. It's going to be 5. And what else we have? X to the 4. Good. Okay, x to the 4. And we're done. Okay, so just make sure that you just draw the line up to here. Okay, this is good. This is excellent. Once we do this, now we can rewrite our formula. We can say that we know what this integral is about. This is equal to integral of. So before doing that, we just go to the side and we're gonna substitute. Okay, so we're gonna say, let me use a different pen here. Okay, let u, what's my u, guys? Okay, if you said u is equal to this guy, because it's right here, you're absolutely right, guys. Good for you, okay? That is going to be 5x to the 4. And if I find my u, I want to find my du. Du is equal to 20x cubed dx. Don't forget your dx. And I'm done. And I have that enumerator. But I put a note again. Do you see that? Note to remember, my a is equal to, guess what? Is 4. Okay, I like the yellow color. So then I go right here and I write my integral, and I just go like, I say, okay, you know what? Let's go and write it down. So I'm just going to pause here so you can write it down. Okay, I think that should be enough for you. And instead of 20x cubed, right here, what do you write? You said it right, du. And then at the bottom, that's my a to the second minus u to the second. And the whole thing is under square root. Okay. Okay, so that's this formula. What is that equal to, guys? Let's put this here, put a boundary line here so you can see that. So this is really equal to this formula that we have. This is really equal to sine inverse of u over a plus a constant, which is equal to, let me get a different ink. This is, okay. All right, so sine inverse of, what is that? U, what's my u? I go back right here, that's my u. 5x to the 4. Okay, divided by a. Don't forget, divided by 4 plus a big C. Okay. All right, guys, I think we are doing good. All right. Okay, finally our last problem. So we're not gonna change our strategy. So we are starting by writing our u. So let u equal to, let me just get a, let u equal to ln x, ln 4x, and then find the du. Du is equal to, remember ln u, I'm just going to tell you ln u is really 1 over u, in other words 1 over 4x times the derivative of the 4x, which is just 4, and we put our dx right there. This cancel with this, so our du is going to be 1 over x dx. Okay, so just remember that. Oh, can I put a note here for you that if you want to integrate anytime you have I know that you know this really well. D over du of ln u. Oops. Ln u. We always do it in terms of u. This is equal to 1 over u times u prime. All right, so just remember that if you just forgot that. Okay, so let's do that. So we know that we don't need this. Oh, just a reminder, 1 over 4x times derivative of 4. That's simple. So now we'll go right here, and we're not going to touch anything else. And let me get my pen back, and let me see what color I choose. I choose green. Okay. So now we have equal sign, and I'm not gonna change anything else. I'm just gonna rewrite my problem, and hopefully I substitute everything. So instead of writing 1 over x dx, 1 over x dx is just du. So I could just write du to make things simple. And what is square root? Square root is just square root. And what's 1? 1 is really our a square. Okay, if you want to put a note here, that's 1. Okay, minus ln 4 to the x is my u, so that's going to be u squared. Okay, now when I have this, I can rewrite this as sine inverse of u over a plus c. You see how simple it is? And this is going to be just sine inverse. What is my u? My u is really ln 4x divided by a, which is just 1, plus a c. I'm done. Okay, there we go. Thanks for watching. I'll see you guys tomorrow, and have a good night. We'll continue. We will do the volume tomorrow. We did area under the curve, so we're almost there. Okay, thanks for watching. I'll see you tomorrow again. Good night.